Let's go ahead and continue our discussion with the formation or birth of stars. And stars typically form in molecular clouds and are called stellar nurseries because this is where stars are born. Okay, so this is the sequence of events that happens, A through D down here. And the first is a dense core forms within a molecular cloud. So the particles in the molecular cloud kind of clump together and they form this dense core. After this step, as that kind of clumps up more, I guess you can say, or collapses into itself, a protostar with a surrounding disk of material forms at the center and accumulates any material from the accumulates additional material from the molecular cloud. So that's B here. C is where we have a stellar wind that starts to happen, but it's confined to the disk to flow out along these two poles. So we have the flowing of the air, or the wind, I'm sorry, not air, this is space. The wind in this disk, and so any material starts to flow out of these two poles, okay? Or along the poles. And after that wind sweeps away any cloud material, it halts the accumulation of additional material and a new star is formed with a disk surrounding it. Okay, now these disks are typically going to be what we see in, let's see, in the formation of a solar system. So we talked about that probably pretty quickly at the beginning of our solar system section of our planets there, but this is that same idea. So we'd have some sort of debris or something left over, quite a bit of material left over in this cloud of, or disk of material. So here are some real pictures of stellar wind. Now, whether they are colorized or something like that, or put through certain, no, it'll be colorized. But anyway, so this stellar wind are protons and electrons that are streaming away from the star. So here is an example of the sequence of events, you could say. So here we have that stellar wind being pushed, or that the stellar wind being pushed out, okay? And it gets pretty violent and kind of starts to slow down, it looks like. But we have that sequence of events. We can also see it in these couple down here. We have that stream, okay? Same here. And in these ones, they are pretty easy to see since we're kind of zoomed out more. You can see that flow of material coming out from the star. Okay. All right. So we have evidence of planets that are forming around these other stars, and just like I was talking about before with the formation of the solar system, we'll see that around other stars. And these planets we call exoplanets because they are outside of our solar system. Okay, so these are exoplanets that are being formed, and this is the idea that we would see. We'd see a star with a disk around it, and it has an accumulation of material. These materials clumping up. And I won't get too far in depth about this, just because one of the videos I'll have for you guys will. And yeah, I just wanted to mention that we know that there are exoplanets. We've discovered a lot of them. And now it's the question of whether we want, or we know, question of whether we know if these are in the habitable zone, and whether they could support life on Earth, depending on what type of material that planet is made of, or if there's a presence of water on the surface, since we know that's how life is formed, at least here, right? Um, so this is kind of an interesting topic to go into, exoplanets. It's something that I would definitely be interested in researching. Um, so this is um, just the evidence that we can see of these disks that are forming. Okay, so let's talk about the evolution of stars now. So we've talked about the birth of stars, starting with that stellar nebula, right? But we want to move on to what happens after that stage. So in our solar system, we have the sun, and it is considered to be an average star. So after the solar nebula, we have a star that's formed. Eventually, it will pop up, start to lose a lot of mass, and it will turn into a red giant, which will eventually um, collapse into a planetary nebula with a small, dense, um, it almost looks like a planet or a very small star here, and that is actually a white dwarf. And we'll talk about that in the future as well. And we will also talk about this death sequence in the future. I just wanted to kind of give you guys a preview. So, again, we have our star, turns into a red giant, eventually becomes a planetary nebula. Okay, and that's when it starts to kind of engulf the other, the planets that surround it, because it gets so close to them, because the giant or the red giant gets so big. And so what's left over is that white dwarf, which is very, very dense material. Okay. On the other hand, in that stellar nebula, if a massive star was born, okay, the massive star is formed, then we'll eventually get a red supergiant, like I had mentioned on the HR diagram. Okay. Eventually, that'll collapse into a supernova, and from that supernova, we can have one of two things happen. We can have a neutron star or a black hole. Okay, and again, we'll talk more in depth about that later on down the road, but just to kind of give you guys an idea of what is to come with this evolution. Okay, it seems like the evolution after it starts to become a red giant or red supergiant, it all kind of goes downhill for them. So it starts to kind of go towards the end of their life pretty quickly. Okay. All right, and I wanted to show you guys some planetary nebulae, I should say. So this is the Ring Nebula. Maybe you guys have seen this. It's got that signature ring look to it, and a tiny little star at the center that is going to be your white dwarf there. Okay. We have a M2-9, which is an example of a butterfly nebula. If you look up nebulas, there's some really cool shapes that happen, but this is one. It's a planetary nebula. We also have NGC 6751. Okay, again, we have that planetary nebula and our small white dwarf there. And this one looks a little bit funky. So this looks like to me that it is still maybe still engulfing its planets, or something is going on that's drastic. And this is NGC 7027. Okay, so you can see that there are different looks to these things. It depends on what angle we're looking at them from, or maybe how they kind of collapsed into the state, or how or what the planets were made out of. It just all kind of depends on how it will look to us. So the next time, like I mentioned, we're going to look at the death of stars. Okay, so stay tuned for that. Also, I wanted to briefly mention that you probably noticed that there are a lot of chapters that I um, labeled as this section, but that's only because there are a lot of pieces I took from each chapter and put them together into this lecture. So don't be intimidated when you see that there's like 3 or 4 chapters covered because I touched on each of them. I did not go deep. I saw in the textbook they go in pretty deep to these conversations, and I don't think it's really necessary for us. We're barely learning astronomy, so I didn't think that it was too um, necessary to go that far in. Okay, so don't worry about that. As always, if you have any questions, please let me know, and I will see you next week. Thanks.